Presented by Caltech.
Well, thank you everyone again for coming. And as you know, this event is to honor our late Professor David Middlebrook, who has contributed substantially to Caltech, who had a tremendous amount of contributions to Caltech. Dave Middlebrook was born in 1929 in Newcastle, England, and moved to the US in 1952. He actually, in fact, took Queen Mary to come here and attend Stanford for grad school. As many of you already are aware, he had a very prolific life at Caltech, starting in 1955 as an assistant professor, going up through the ranks, and being here actually an active faculty member for more than 45 years. So it's almost close to half a century. He graduated 36 PhD students, several hundreds of master's and bachelor students worked under him, and he taught more than 2,000 students in his classes over the years. The way we know this is actually interesting. So because about like a year and a half ago, they were cleaning up one of the labs, one of the offices in Moore, and they were throwing stuff out, and almost from inside the garbage, I saw these. It says roll books, 1955, 1958, and I'm an inquisitive kind of guy, so okay, I'll have to see what's going on. So I pick them up and I find out actually these are Dave Middlebrook's roll books, starting from 1955 that he started at Caltech, all the way to basically 82 when they were computerized. And looking at the number of students, the sheer volume, and after that, of course, he taught quite a few courses. So if you have had a class with him, it's likely you can find yourself in this. I was thinking, are there some privacy issues associated with this or not? But I figured after 34 years, because the last one was 82, the statute of limitation must have passed. Your achievements are not going to be determined and established by the grade you got in here anyway. But you can take a look at them afterwards. Dave also he was a prolific publisher. He published 2 books. One which was arguably the first textbook on transistors. And he, in fact, talks about at some point about how he basically started reading Shockley's papers and trying to kind of translate that to something that engineers can relate to. And if you look at it, a lot of subsequent books on transistor physics and all those things are influenced by this. So are a lot of books on circuits. And he had another book on differential amplifiers, again, which you can see if you look at subsequent books that were written by MIT people and Berkeley people, you will see exactly the influence of this. It wasn't until I read this that I saw, okay, this is where some of these ideas came from, about the ways to think about it and the way to represent it. In any event, I can stand here and talk about David Middlebrook, but we have something even better. We can let him talk to you. So there is a 1-hour clip of him talking about his life story. And we are not going to show the entire 1 hour. So this is like a 5-minute excerpt from that. And we have that entire clip. So if anyone is interested in hearing it. And this is from 1995. A party that he threw for himself. And he basically said, and I quote, "I wanted to have a good party while I am still active." So he knew how to enjoy life. He had a lot of interesting interests beyond the technology, and that clip is actually quite enlightening about that. We also have a very distinguished panel, which after the video we'll go to and talk to. We have Professor Slobodan Chuk, we have Professor Bob Erickson, we have Professor Carver Mead, we have Professor Richard Muller, and we have Dr. Tang. And all of these have had close interactions with Professor Midlebrook. In fact, the question arose, who was Dr. Middlebrook's first student, whether it was Professor Mead, Carver, or Richard. And we were going back and forth, and I'm not going to get into the middle of that fight. I'm going to let I'm going to let the giants duke it out. But needless to say, in the roll books, actually, if you look at them, both of them took the class at the same year, and both of them got an A, and they were only. So they're both top of their classes. So you can see that it's no accident.
Yeah, Middlebrook never gave A+. Okay.
Have high standards, right? Okay. Well, so I'd like to basically, I don't want to talk more about this and we'll go back to the panel, but let's just play that video clip if you could.
Really, what I look back on these 40 years, and it seems to me to fall into three phases, which I have come to refer to as my three technical incarnations. The first one was the semiconductor area, the second was power electronics, and the third is a concentration on teaching methods and this design-oriented analysis phrase, which you've already heard mentioned, and that's what I'm trying to promote these days. But aside from all the technical stuff, and I'm really not going to say much about that at all, many of you here, I suspect, may not be aware that music has been a large part of my life since I was a teenager. I went into the RAF. I had to do that before going to college because colleges were filled with the returning vets at that time. So you had to do your two-year national service. And my father was a school teacher, and I always swore that I would never teach. That's my father a few years before he died, and that was probably around 1972 or so. But when I went into the RAF, I did a course in radio and joined the station dance band. And I didn't want to get posted away from that, and so the only way I could get to stay on that station for my 2 years was to become an instructor, which I did. And so that was my very first job, which was teaching, which I never intended to do. Well, it was actually because of music that I got interested in electronics, because that was the beginnings of hi-fi. Anyone remember fiber needles? Style, you had to sharpen them. And you would barely get through one side of a 78 record before the point would break off, and you'd have to stop and resharpen. Anyway, that's how I got interested in electronics, and that was vacuum tube days, of course. And so I wanted to build myself an amplifier, and that's a vacuum tube amplifier. I was very proud of that, because I built the whole thing, including punching the chassis and crackle making the paint on it. And it was actually the second amplifier I designed, although it was the first one that worked. Does any non-technical person here remember how a vacuum tube works? Caltech decided they needed to get into the semiconductor field, so they came to interview at Stanford and made me an offer, and I said, well, I don't really want to teach, but it's only a 3-year appointment anyway, so that'll put off the decision again about what job to take, although they weren't lousy jobs this time. So I came to Caltech in 1955. That was the book that I wrote shortly after I came here, and since the title has already been mentioned. Those funny-looking objects on the cover are 2 transistors. That's what they looked like in those days. They were discrete transistors. And the reason I wrote the book was, after going to that course given by Shockley, etc., and back at Stanford, I was totally on my own to try to learn something more. And so I read Shockley's famous book and his papers. The paper in which he invented the junction transistor is a classic, published in the Bell System Technical Journal, page 431, 1949. And trying to understand what Shockley had done, then this is the book that resulted from that. This was my translation of Shockley for engineers, I hope, as a matter of fact. The key would be that almost every important turning point of anyone's life is the result of an accident. But that doesn't mean there's nothing you can do about it. And so being prepared to take advantage of accidents is the important thing.
All right, well, now that we've heard from David himself, I think it's time to open it to the panelists. If each one of you could say, or we can start from Shuga, but just if you could.
I would propose that Professor Mead and Professor Muller decide who's going to come first.
I think we should decide that you come first. Because you got.
Thank you very much, but as a matter
First time you admitted to be second, right?
no, that's not the case. It's absolutely certain that Carver is the first recipient of a degree on
Microphone. I can just turn on.
Okay, sorry.
Let's see you.
It shows the green.
Yeah, I think.
Green is
I
on,
think
right?
they're controlling it from back there.
It's on.
There you go.
4. Okay,
Now that's better.
are you hearing me back there?
Yeah. Yeah. No?
Do you have a hand mic?
Oh, okay. That always is.
That's just.
Okay, what I began with is certainly Carver and I know each other from the earliest days of Dave Middlebrook being on the faculty here. That was in 1955, and that was the year that I came to California to become a student here at graduate school at Caltech. And I do remember, and in fact, having just heard this discussion by Dave, how I had very much tried to see what Mr. Shockley was saying in electrons and holes and semiconductors, because my undergraduate days, which were at Stevens Institute of Technology in New Jersey, close enough to Bell Labs that we were very excited that things like that had just happened. But there was no one on the faculty that had any background. After all, the transistor invention is 1948, and this book was out in 49. And so those early 50s, we were learning lots about vacuum tubes. So I was interested. This looked like a really great frontier. And I remember speaking with Dave on one or two occasions, and he just reinforced that. And he told me that I should be in his course, and I would find out a lot more, and I certainly did. Now, I think I'll pass this without going too far further, but at any rate, Dave was an extraordinary influence in my life. He actually is the reason that I did decide I wanted to be an academic. I wanted to have that kind of life, an opportunity to be interactive with young people with at the age that they have such enthusiasm and in many cases such gifts to let's say to tend to and to become proficient with. So I had, just to go on, I've got a little bit behind Carver because, as a matter of fact, I took a year off to get married and to work at Hughes it was Hughes Aircraft Company in Culver City. But then with the enthusiasm that Dave Middlebrook had shown, I came back under National Science Foundation fellowship and worked with him, finishing my degree in 1962.
So now you've got to say something.
Now I have to say something. Richard and I were in the I think it was the very first class on that transistor stuff that was taught out of that book right there. They didn't look like that when we had them. They didn't have this glossy cover on them. They were just a plain blue book. And it was a remarkable time. I vividly remember that Dave was the person that introduced me to solid-state device physics. And even though that's not the direction he went after that, he had done the heavy lifting of taking this thing of Shockley's, which none of us could follow, and turning it into something that an engineer could get their head around and do something with. And for me, that was a lifelong love affair that has never ended, and I owe it to Dave. He just, he made that sparkle. And he had this way, many of you took his courses, and he was one of these great pedagogists. He could just explain things in such a way that every step followed from the one before, and it was astounding. I was never able to do that as a teacher, but Dave did it, and he did it in spades. And I think the last contact I had with Dave was when he sent me a little file that was a little movie he'd made where he was explaining the extra element theorem that he had invented. And this was, when was that?
80s.
In the 80s, yeah. And I know one of the people here made the comment after Michelle F. Ross's talk that some of her way of reasoning looked a lot like the extra element theorem if you removed or put back in the extra element. And when she said that, I immediately thought of Dave and the last communication I'd had with him. And we owe Dave a lot in many, many ways. We miss him dearly.
Well, I just look at the 1974-75 record in Professor Dave's book, and I see my name there, and I see fellow names Heinz and Zagel, and we got 28 points, an A, and everybody else is lower, but there is no A+, okay? Now, I tell you another anecdote about the A+. I applied to Caltech, and sometimes in March that year when I applied, I get a call. And I get a call from Professor Midlebrook. And I was surprised, you know. Professor would call me, I just applied and didn't expect anything. So the reason I call you is because you're A+ student at Santa Clara, but I have another student from MIT who is C-, and I don't know what to do. Because Santa Clara at that time was not even in the top 50 students. And then I said, Professor, I don't know, you have to decide by yourself. And he actually did. Later I learned, he called my department chairman, he gave me the only A+ in his career of 40 years, and they talked to him and said, why did you not keep him there? And I appreciate both gentlemen, because my professor there said, I would love to keep him if he wanted to work in my field. But he chose your field, and I don't want to affect his career. And I must say, the reason I came to Caltech, because Professor Midlebrook sent me an article. And it was the first article that he was writing actually here. Gene Wester his PhD preceding me, and they wrote the first paper on a boost converter and trying to find out why it has a non-minimum phase, it's unstable. And when he sent me this paper, I looked at myself. I had so many years of electrical engineering, nuclear engineering, control systems, and here I see a very simple circuit. One inductor, one capacitor, one transistor, and one diode, and I don't know how the hell it works. So I decided it might be very, very interesting. So when I came to Caltech, Middlebrook had completely different looks. It is not what you see on a video. That was 10 years later. His look was pretty intimidating, at least to me, young student coming. He had a mustache, a beard, and he still had a pretty heavy British accent, and I think a British attitude too. so he was, when I came to one of the first sessions I had with him in his office, when he invited me, he has drawn a boost converter, and the same one that I came to Caltech, and he put his legs to rest on a table, and he says, how does it work in a light load and a no load? I have no idea. So that was a starting point. Then when I finished at Caltech, I will make a comment regarding this. Actually, first edition of Introduction to Junction Resistor exactly this way. It was thinner. This must be second edition with more material. It was same cover, very thin. And I went with him to the Rent Corporation. We're looking for some funding, etc., in Santa Monica. And one fellow there, we were in a break, tells Middlebrook, you know, and he was much older looking than Middlebrook. And he says, you know, I studied and learned a lot about transistors from book Introduction to Junction Transistor Theory from a guy named Middlebrook. It couldn't be you. And Middlebrook looks at him in his British way, says, I'm afraid it was me. Then I would like to say one thing. Professor Midlebrook and me, we in the science field very often change the fields. Try one, and if we don't find ourselves in it, try another. Professor Midlebrook, what I know, I've been with him for 26 years, forming and helping grow the power electronics group at Caltech. And he was very humble in a sense that he said, I came to the United States and Shockley, to hear Shockley give a summer course on a transistor, which was then brand new. He just invented it, I guess. And he said, I came to Caltech, and then I wrote this book of introduction just to translate to engineers how to use this device. And it was very true. You know, I don't know if engineers here can appreciate it, how he did translate this to very simple circuit. Transistor is just a current source, amplifier, and emitter resistance, depending on a control current. Why I say that? Because back in Belgrade, 1966 to 1970, I had 4 years electrical engineering, and we got a Z parameters, Y parameters, about 50 different things for single transistor. So how could you make any circuit and any model out of it? So I think, but eventually I feel that Professor Midlebrook really fell in love with the power electronics. That in 1968 he started consulting, and in fact that's how he got into it. Outside of on NASA, they had some boost converter on a satellite which went unstable, and that's where Gene Wester was his first student in this area. He started also power electronics because 1970 was the first conference in power electronics, I think in MIT, but 1971 was the first conference, a second conference at Jet Propulsion Laboratory, and Professor Midlebrook was chairman. At that time, power electronics field was called, conference were called power conditioning. And we quickly changed because it sounded, you know, low class and low level like air conditioning. So we first changed power conditioning, power conversion and electronics conference. And then later it was simplified to power electronics, and it stayed that way some 20, 25 years. I would say Professor Midlebrook was really very instrumental to bringing this field to be recognized as academic and research discipline. We were supported originally by NASA. Together we have grown a group to about 35, 36 PhD students. Just to give you how much we are productive, I think Professor Hajimiri doesn't know that, but this book was his first 2 books in the other area. But from 1976, when I finished my PhD, 2 years, 74 to 76, from 76 to 1981, we published 2-volume books, total over 600 pages. And from 81 to 83, we published another 21 papers of 350 pages. So, and many consider that as many people use that as a textbook and use it as a reason to get into this field. Because we were writing the papers at the time, irrespective of lengths, 20, 30 pages. Later, conferences established page limit, and you had to pay if you're over that limit, and Professor Midlebrook and me decided, look, we need to educate this field. We'll take whatever it takes to explain it, and we'll pay for it, and we did. So that's still, I think, Middlebrook stayed in this field not only till 1998 when he retired, but another 12 years he was a regular visitor, regular attending a major conference in this field in the United States, which is Applied Power Electronics Conference, actually up to the couple of months before he died. So I think I have traveled with him throughout the world. We taught outside of Caltech, something like 4,000 engineers throughout the world took our courses, and I learned a lot of him from him in the style of the lectures. You know, it was very difficult to match him in that category, but you know, I tried over the years to be as good teacher as he is and researcher. So I think the whole world should owe gratitude for Professor Midlebrook for starting this field. I should mention one other thing that I enjoyed in particular, and it's not just make a compliment because Carver Mead is here sitting on the left-hand side, but we fell in, each time we had a PhD exams, I was looking to put Carver Mead on my committee, students, because if he checks it out, if they check it out with him, then they're okay. So and I think he returned me a favor, so even though he moved into a different field of integrated circuits, and I moved into power conversion, it's kind of interesting that now, after so many 40 years, there is a convergence. There are new type of the devices. And I remember when Professor Mead gave a talk, and he said Shockley loved so much his transistor that he wanted to make it as a single device. So he couldn't get to another level to make integrated circuits, which we have so many now. In a power conversion field, up to now, we use the switching devices because of the power, which had a vertical channel to increase the power rating. Now there is a new kid on the block, which is called gallium nitride devices, and guess what? It is a planar device, and you can understand, and it's about 5 times smaller in size, much faster, but you can put now 5-10 switches that we need in a power converter on a single chip of the size which used to be, you know, one transistor before, small package, together with the drive circuitry, etc. So now the challenge is how do we get rid of magnetics, or do it in such a way that magnetics is reduced 10 times or so. I think, again, in a conclusion, I would say that really Professor Midlebrook had a great influence on my life, but more than that, the whole world should be thankful for him starting this field and being this long in it. He is really one-of-a-kind scientist and a complete human being. You know, he treated his students fantastic. I think I see many of our students here, and I'm sure they'll all confirm that he was an outstanding teacher and outstanding example. Thank you.
Thank you for that detailed description. It's good to put it in historical perspective, you know, when you see it from starting from the first students and the progression of fields. And I guess next we have Bob Erickson.
They forgot to ask in the question, who was the first student of mine?
Okay.
Yeah, so I, first of all, I was surprised but thankful to be here, and certainly I couldn't miss coming to honor Dr. Midlebrook. I took his EE 114 class 39 years ago. I was a PhD student in power electronics 35 years ago, and I've been on the faculty at the University of Colorado for 33 years. And I just made a few notes on, I guess, from the perspective of teaching for 33 years, you know, what sticks with me the most about Dr. Midlebrook. And certainly, you know, it's power electronics, the teaching, and his design-oriented analysis. I think Slobo said it very well about the power electronics, so I don't need to add much to that. Certainly he was, more than any one person, the academic leader that I think turned power electronics into a recognized and organized discipline of its own. Teaching EE 114, the thing I remember most that we all remarked on was that He gave lectures in which he spoke in complete paragraphs that has a topic sentence and several expository sentences and a concluding sentence. I've never seen anybody before or since be able to lecture like that. And when he gave his presentations, like papers or tutorials at conferences, he spoke in a similar way. And so, you know, always the room was packed, and his way of thinking was highly influential as a result because of how he could explain things. The first paper I wrote, he told me to explain it like Feynman. And so certainly in the 70s and 80s, we all knew what that meant. I'm not sure whether that lives on or not anymore, but I hope it does. So, you know, understand the essence of the problem and explain in an intuitive and physical and clear way. Later in power electronics, we'd go to conferences and people there maybe didn't know who Richard Feynman was, but they would say, explain it like Middlebrook. So that was the power electronics version. And so I think, you know, he had a lot of wisdom to impart on how to think and how to approach complex problems and how to explain things well. For me, his early papers on input filter oscillations and switching converters were the example of how to write a paper. And that's, you know, a craft that in the academic business we need to learn. That's especially important if you want to influence anybody else. And especially his first paper on input filter oscillations had an introduction that went, I think, for 4 pages in the paper. And it was the most remarkable, you know, introduction for a paper that I've read, where, you know, he would develop his ideas and his viewpoint on the problem, explain the larger context, and expose the high-level essence of the result that he was going to present. I think today's page limits probably don't let us do things like that anymore, but one of the things we did in the group that really came from him was to learn how to write papers like that, to explain things. And there was usually a little bit of an informal competition of who could explain things the best, which usually meant who could write the longest paper, and generally Slobo won.
Well, let me answer that. Middlebrook and me agreed at one point, and he said it's very easy, it's much easier to write a long paper. And because we don't have a time, we are going to do and write the long papers, because we want to put everything what we know and educate the field. And it's true, if you really want to spend 3 times as much time, you can reduce a paper by 60%, but then you wouldn't be doing the other research and the other material. So that's my rebuttal.
Design-oriented analysis certainly was a major topic of EE 114, but as well of the research that went on in power electronics, and then of his third topic of his career. In reflecting on that, I think it may be as important, or the most important, as far as I'm concerned, of what he did. And he had all the stories about engineers, getting out of school and not being able to function, and falling off a cliff and so on. But really what this was about was teaching wisdom of how to approach a problem and how to think the right way. And he wanted to develop a methodology and a syllabus of exactly how to teach those things. And some people were influenced by his syllabus, and I can tell you from going out to another university, some people weren't and didn't believe in it. But at a high level, what he was really trying to do was right, and it was teach wisdom. And he imparted it on all of the students in the group, and I think all of his 114 students as well. I'll say in my experience away from Caltech, it's been challenging to convince colleagues that we should take time out of the syllabus that is chock full of all kinds of little technical things to teach and take some time off of that and teach how to approach a problem and how to cope with the complexity that is in the real world. But you know, the choice is to either give up and assign only trivial problems, or to expect students to be good at highly complex algebra and how to interpret the result, or to teach his design-oriented analysis, I see as a third way to do it. So I'm fortunate at Colorado to have two colleagues that also took EE 114. And so the three of us will get together and teach that and work it into our courses. And we even teach design-oriented analysis there. But it's not a easy thing to do in general to convince everybody of that. So I'd say looking back, 35 years later, this design-oriented analysis work was his way of imparting his wisdom of how to think to the rest of us. And to me, that was what made him so successful in power electronics, was having that wisdom and applying it. And certainly it's what I remember the most.
That's great. Thank you very much. Last but not least, the last student of David Middlebrook, Don Tan. He's a senior manager at Northrop Grumman Aerospace Systems, and he will tell us a little bit.
Thank you, Ali. And let me just make the facts correct. Actually, I came into Caltech in '89, January 1st. That's 100 years of Rose Parade. And then Professor Chuk actually was my supervisor. But I believe Midlebrook is my thesis is the last thesis he advised.
I see.
Okay, just to be politically correct. So I certainly has the distinct honor to join this panel, distinct speakers, and then I'm probably most junior. So I must say that the way I would describe Middlebrook, I speak to many of the, when I travel across the world. So Middlebrook is the engineer's engineer, professor's professor, researcher's researcher, and the writer's writer. So I think that's probably summarized his statue in our industry. So within the power electronics society, so once the word's gotten out for his passing, so people start talking about he's the father of the modern power electronics. So then pretty soon, then the conversation carried on, how do we gonna best memorize him? So we established an award in power electronics. It's called R. David Middlebrook Outstanding Achievement Award in Power Electronics. So that's sponsored by the IEEE Power Electronics Society. So at that time, I was a vice president for the society. Then later on, I had a distinction honor to extend the two of the certificates to the two of recipients in 13 and 14. So on a personal level, I actually had the privilege to work with him on the writing papers that Bob just commented on. I may just, because we are writing the current programming, for those in our field understands the details, the paper, because some well-known authors within our field actually challenge some of his results. So when we writing that a paper, so I get a really intimate knowledge to work with him, and I learned really firsthand how to write a good paper. So he basically, to summarize without going through the details, he basically says you write it as a technical person. Then you read it as an alignment to understand, say, if your point cross through or not. And then you read it as a proofreader for your grammar, for your everything else, typesetting. So I said, I have to be three. Yes, you have to do three. You have to play three roles. So first, you as a technical person, you write it, because it jot down your thoughts, what's your accomplishment, what's the technical merits. And then I found that's pretty profound. So I think that benefits me quite a bit. Another thing I'd like to add on to all previous speakers that is that actually he emphasized on the importance in the modern academic world, technical world, of the importance of communications. Because I remember I was in a conversation with him, say, if you have a bright, the brightest idea in the whole world, and then you try to communicate to convince your boss, hey, this is the brightest idea. But somehow your boss never understood you, or you failed to convince him this is a good idea. And then he said, whose fault is this? And then he said, it's your fault. So that's really profound. So in other words, if you have a great idea, so you need to really master enough communication skills to really convince your boss and your peers. That's really important, especially for nowadays the communication is so fast. The technology is updating so fast. So communication skills is very important. So I must also say, personally, I certainly benefited from Professor Midlebrook because we actually had a seminar together right after I finished the Caltech. I finished in '93 November, but I got my degree in '94 because I missed the June submission deadline. So then we walked in '94. So we did a seminar together. So that's my career started being lifted off with him. So that's to do that, I'm very grateful.
Great. Well, thank you. So I'd like to now open it to the audience. And please, if you could do us a favor, keep your comments brief and the responses from the panelists brief so we can get to as many of you as possible.
I have to share a Middlebrook experience with everybody. I took I think it was 114 in '72 when I was working with you, Carver, on the chip. So I was one of the 8 students left standing that did the first chip design at Caltech under Carver. What a slave driver you were. He offered us $20 staring into the light table if you could find a defect before we taped out the mass plates. But anyway, we worked for slave wages back then. But here's the Middlebrook experience. How many of you remember the old days at Caltech where you stapled your homework upper left-hand corner, folded it lengthwise, and turned it in with your section number? All right, well, anyway, that was the style back in my day. And the first Middlebrook homework assignment was a circuits analysis. And all by hand, so all the trigonometric expansion and simplification, and then, of course, part 2, change this circuit element, do it all again. Oh my God. So we turned the homework in the beginning of the second week. And some people folded this big, thick wad of paper down the middle and tossed it in. Other people gave up, just stapled it, and one stack of paper, 10 pages, and just tossed it in there. And David comes into the class without saying anything, because it was the first lecture, second week, picks up a folded homework, picks up an unfolded homework, and says, well, I see that some of you already realize that in this class we don't fold our homework because later on you won't be able to. That focuses the mind.
Great. Thank you. So any other comments from Charlie?
I go back a little bit over 50 years, but I think it was Applied Physics 129. Dr. Middlebrook was, it was semiconductor physics in those days, and homework was a little bit different. He would give us an impossibly difficult problem, our job once a week, and we only got credit for the solution if it could be done in a single page. So fundamentally, one had to come up with a simplistic model that was predictive for what the answer we needed. And that was one of the 2 things that was really important for me. I've got to put you on the spot, Carver, because I took your circuits course, and after midterms, I simply wasn't getting synthesis. I decided it was going to screw up my GPA, and so I dropped your course. You never forgave me because I came back for a master's degree, and I had to grade the course.
Thank you. Thank you, Charlie, for that great story. There's one, if you could pass that, just on your table. Yeah. Oh, okay, so yeah, Gene, go ahead. Maybe we can start back there and then we'll come here. Go ahead.
I'm Gene Wester. I had made a few notes of Middlebrook specific instances that I wanted to share with you. He had this ability to organize his thoughts, as some of you expressed, and present them so elegantly that it seemed obvious, but only after the fact of him demonstrating it. He had, at that time, there were I think 3 different sliding blackboards in the presentation room, and there were about 3 across. And he had this system where he would go through and fill one board, and then go to the next one, fill that board, fill the next one. And then by sliding them up and down, you could see the progression of about 6 complete boards full of background. And then he, when that became mundane, he developed transparencies during his presentations where he'd have overlays and show the progression of ideas, modifying circuits, adding analyses, and so forth. Very state-of-the-art in a way that was so insightful but hard to take notes with. And he used different colors, so some of us were coming with a whole array of different colored pens trying to keep up with his notation progression. I was so impressed while I was writing my thesis. He went away on one weekend, had a cabin in the mountains that he would retreat to occasionally, and came back with a completely finished paper, and there was no redoing or editing. I mean, it was done. It was just submitted. He was that so organized and such an inspiration. And then his mark on the field of establishing power electronics as a discipline that basically involved the integration of power along with the concepts of control with the superposition of efficiency. And that's basically the triangle that he established as what became known as power electronics. I guess the other thing I was mentioned, just that homework example, he typically did not give finals exams or even midterm exams. Your grade was based on homework, and there was one homework problem per week, and depending on your skill and insight, you'd normally end up extrapolating what was discussed in class and applying it to this challenge of a problem. If you understood it, you might come back with a solution that was half a page. If you just ground through the algebra, you might come back with 10 pages. But usually the one that came back with half a page was the one that was the elegant and understandable approach. And then because he was an Englishman, I guess that carried over. There were parts of my thesis that I rewrote 2 or 3 times. He was notorious for, spotting dangling participles and whatnot. And he wouldn't tell you, he wouldn't make the correction on it. He would just say, there's a problem I noticed with such and such. And you had to go back and figure it out as to what it was and how to correct it. And his students all shared that as a common malady. Anyway, he was so important and inspirational in my life and in setting my course for a career. And I think the world of him and thank the world for him.
Great. Thank you. We have another comment in the front. Yes, go ahead.
I'm Sanjoy Mahajan. I was Carver's student when I was here, and Carver said, well, you should take Dave's course. I think you'll like it. So that was E114, and it's stuck with me for everything I do. So I've written 2 books since then. One was Street Fighting Mathematics, and one was The Art of Insight in Science and Engineering. And I look at both of them as footnotes to one comment Dave Middlebrook said to me. He said, people say that, an approximate answer, well, that was good enough. No, an approximate answer is better. And that's always stuck with me, and I think everything I do for the next 30, 40 years, may I be as fortunate as Dave Middlebrook, I will be a footnote to that, to what I learned here, and a lot of it from Dave Middlebrook. So I honor his memory, and I'm grateful to be here and that we can all do that together.
Yeah, no, thanks. More comments in the back? Yes.
So I also took Middlebrook's class as a sophomore, and he had a reputation for being really tough. But I can tell you that I was he put some equation up on the blackboard, and I was overwhelmed, so many terms, I didn't know where to even begin to solve it. And yet he just gave us his insight and just slashed through the whole thing and said, this is what's important. And if you survive the class, I'm speaking from the experience of one of my best friends who came there. He was interviewing, and he noticed while he's being interviewed that the guy had Middlebrook's book in his shelf. Was, oh, is that from Middlebrook? And all of a sudden, the guy just had such, how can I say, he's practically hired on the spot, basically. So, because he had taken the class, he gained the insights. So, and I'm still learning anyway, but it's amazing how he could cut through and just simplify things to what was really key, what was important. So, thank you.
Right. So I have a little personal anecdote about Dave Middlebrook. When I was a grad student, my advisor had constantly referred to this expression of low entropy expressions, writing expressions in a mathematically low entropy. And he gave credit to David Middlebrook, so I had heard his name. So when I came to Caltech, it was the same. I started the same year when he retired, 1998. And I met him, and he was a very, very nice person, as all of you know. And he basically gave me the entire collection of the VHS tapes of his class. And that was very generous, because I was just starting to say, how do I teach and all those things. So I went through the class of 114, which is the class that I've taught since then. But it was remarkable because, although I was never his student directly, I could see all of his influence in the tapes and all those things. The other interesting anecdote that many of you may or may not, some of you may be aware of, is that if you look at the academic genealogy of David Middlebrook, David Middlebrook's advisor was Joe Petit at Stanford, whose advisor was Fred Terman, who was advisor to many people, including Hewlett and Packard and all those people, and who was student of Vannevar Bush. Vannevar Bush, of course, everyone probably knows, and who was a student of Arthur Kennelly, who was an apprentice of Edison, who was homeschooled. So all of you guys who have worked with Middlebrook, go to, you have Thomas Edison as your academic ancestor. Yes, exactly. So that's another interesting thing. We have time for one or two quick comments, and I have some closing remarks I'd like to make to stay on schedule. Any other comments from the audience? Anyone else who would like to make a comment? Anything else from the, did I see a hand? Sorry. No? Anyone from the panel? I guess.
Yes, well, many of the comments really resonated with me because, in fact, Dave had this very profound influence on the direction I took, but he certainly also was, as described, very persuasive in the way in which he guided you on effective writing. And so one of the things that I really have the most pride in is, over the years, I did write a textbook in the same general area, by which time David moved on to the power electronics area. And I recall talking with him about how he had put his book together, and the sequence was my going up to Berkeley and teaching the transistor course there, using the materials I had from Middlebrook's class and his textbook. But shortly thereafter, as many here will remember, the Andy Grove Intel fame had written a book called Physics of Semiconductors, which touched on some of the points that really had to do with practical applications that were not in Middlebrook's book. And so we used that for some time at Berkeley, and I had the privilege of knowing directly Andy Grove and talking with him about this book and saying, well, as these years have gone by, it certainly needs some updating. Are you planning to do a revision? This was about 4 years after the original publication, and he said to me, well, you know, Dick, I really want to make money. He was then very effective person at Fairchild, and shortly thereafter came the Intel days. So I took that as okay. The field was open, and I wrote a textbook. Again, though, being heavily influenced, as has been pointed out here, with the philosophy that Dave Middlebrook had, and even more overwhelming, I was privileged at Berkeley to be in a department with high influence by John Winery, who's the co-author with Cy Ramo, also from this institution, of a textbook which I consider one of the finest done in the electrical engineering field. And so I had a number of discussions with, and took his advice that a very good thing to do is to have a co-author who has real interest in the field and real capabilities, as he had with Cy Ramo. And he told me about how he and Cy would get together on a weekly basis and read each other what sections they were writing and talk about what could be done better and how that really influenced the success of Fields and Waves, which, as you know, is still being published in revisions as now Fields and Waves and Communication Electronics. At any rate, I worked with Ted Cammons, who was in at Hewlett-Packard, and the textbook has been very successful, and one of the real things I can credit a great deal to Dave Middlebrook's influence. So that's a point I would make here. Thank you.
All of them about 70 to 100 tapes. They're still on VHS. Some of them I converted. But most important, what I want to make is Professor Midlebrook also participating in that group effort. And he made a number of presentations on key topics, not just 10 minutes, but the 2 hours tapes and so on. And I think it will be very important to preserve that and his legacy. So what I'm doing now, transcribing first his videotapes into and putting it up on YouTube channel. I have a YouTube channel. We'll post it. Actually, this morning till wee hours, I was doing already a couple of tapes, thinking that I'll do it today. And it's very easy to get to the channel. Just put my first and last name, because both are so strange that you won't get anything else.
Any other comments? Any more comments from the panel? No? All right, well, so, I'd like to wrap it up, and, as you all know, just basically, David Middlebrook is, has been a beacon and backbone of Caltech, and, today actually we have an extraordinary opportunity we've been thinking about how to honor him, and, there are 2 matching grants we've been able to achieve. One is from Gordon Moore, and one is from an anonymous donor, so we're thinking about establishing a fellowship, a graduate fellowship in electrical engineering in his name. And right now, because of those matching grants, we are at the point that I think if we raise $375K or more, we can actually have a full fellowship, which generally costs more. And if you're interested in that opportunity, let us know, and we would be more than happy to talk to me or talk to Laura in the back. I think this would be a great way to acknowledge and keep his name alive here, beyond these events and all those things. I mean, once you have something that's named after him. And and last, I think as a parting thought on this process, I think I like to use one of a quote from David Middlebrook himself. He says, "The best reward for any teacher is for a student to tell you that something you taught them was useful." So with that thought, I'd like to thank you very much for being part of this panel discussion and this lunch. And we'll meet you back at Ramo for the afternoon sessions, which will continue, and then we'll go on to the lab tours and the rest of the events. All right, thank you very much.